Only 8 people out of 80. Yeah, wait for 1 more minute and then we'll start. Okay then. Is my screen visible? Anyone? Shazadi, Bhumika, Rakshita, Lavanya. Is my screen visible? Yes or no? Hello? Okay. So am I audible? Is my screen visible?
Yes, sir.
Okay, thank you. So last class we discussed about the formation of internet. So LANs together connected together to form a wide area network. So almost covering entire globe and the different kinds of connections, including satellite communications of the optical fiber, of the intercontinental fibers, and so on. And the problems associated with respect to ISP and ISP or service providers. So how internet works or the who is internet service providers, almost how he gains the profit, some issues or the controversial issues in the second video, and normal base framework how internet works was discussed in the first video as such. So after that, our intention of exploring internet is with respect to how much quality of service with respect to real-time operating system or the real-time task requirements is provided by the internet. Or, support for real-time communication as such. So preferential treatment needed to be given to real-time traffic. We have already quoted some kind of VoIP packets. An example was quoted voice over internet protocol packets. So where they can bypass the lane. So they are given a higher priority whenever they occur at they approach a router, switch, or some any network node for that matter. They are not put in a queue, so they are bypassed to the queue, and finally they reach their destinations fastest, or so they reach their destination within their deadlines or within their validity. If I am speaking with respect to the communication aspect as such. So a contact between nodes and the ISP needs to be established. So minimum guarantee or the whatever the ABO and guaranteed probability, so absolute breakdown and guaranteed probability. So these were the two aspects with which 802.4 and 802.5 were discussed previously. Similarly, some other aspects may be minimum required bandwidth, minimum interval of time. So some aspects have to be discussed or then agreed between the service provider and service extractor. So that ISP stands for Internet Service Provider, needs to ensure QoS guarantees. At the same time, sender node needs to meet bounds on traffic. So, can you send a bursted kind of traffic, or can you slotted aloha, and different kinds of traffics, whatever you can imagine. What is the nature of traffic, and whenever we say that it has to be go for real-time traffic, there should be predictability, and hence boundaries should be established with respect to the amount and intervals as such with respect to traffic. The ISP should be able to handle misbehaving nodes. So if somebody is just pumping the data or jamming kind of messages, so he should be kept out of the network. It is the service provider's job as such, who is misbehaving and in what manner is misbehaving. So qualification of that, or the how do you evaluate somebody is misbehaving, and then you treat them separately. It's as good as any. If you have studied a mobile communication, so you list in white list, black list, and gray list kind of approaches. So whitelist is normal customers or normal consumers. So you provide the services without any query as such. Now suddenly you have seen some suspicious behavior with respect to one particular node. So maybe I take an example of cell phone communication as such. So normally all over India communications not an issue as such. If I'm communicating more to Islamabad or something of that sort, so that or enemy countries, uh, or international calls are more, so then you, it may be, so I'm maybe calling to my relation, but whenever you go outside the country or you start cross country communication something like that, so whenever that starts happening, so my nature is suspicious, I will be put into the gray mode. So that means they transact or intercept my messages and nothing suspicious or nothing harmful is seen, then you are allowed to proceed further. And again you may be jumping between the white and gray, because that behavior itself is suspicious. Blacklisted, yes, there is a firm evidence that particular node always communicates with respect to intention to harm something as such. So whenever you have proof for that, then it is automatically blacklisted. So particular SIM number, IMA number, IMSI number, whatever you are stating that. So that communications with respect to all the node are blocked. And that's how the things has to be worked out at service providers. So whatever the scenario I gave is with respect to cellular communications as such. Similarly, whenever ISP or internet service providers is seen, it is much more complicated than the simple SIM number or cell number, IMSI number. Complex ಇರ್ತದೆ. So guaranteeing QoS is shaping and policing. Shaping and policing is how do you make sure that the traffic is shaped appropriately, so that required bandwidths are catered, no traffic jams. Policing is how do you make sure that it's in a proper manner. So when do you require a traffic police, or how do you manage your bandwidths for that matters. Basically, there are rush hours where I really require traffic signals or policing, so that one particular channel is not blocked. So there is a communication across, if there are four lanes and say, if you can imagine a traffic signal, so that nothing is blocked, so there is a policing. So you buffer some, you put a red light, so there is a buffering. After that you allow them, so that then there is a least traffic with respect to that particular channel. Whenever again there is a sufficient traffic, then make it that move that particular traffic as so on. Sort of scheduling policies and switches. Fair queuing, awaited fair queuing, so it depends on how do you want to make that policies. So again, whenever we are seeing trafficking in terms of QoS or the internet service protocols, or the that are to be discussed with respect to real-time applications. So how do I correlate or give an analogy is basically the same traffic control system, or the same traffic policing happens, but there are special packets, something like ambulance, fire brigade, so maybe MLA MP. That's how the there are special class of vehicles or packets, they have to be dealt differently, and the routers and switches or the intermediate nodes will know them, and they will treat them differently. So that's how any traffic police will identify there is an ambulance, and he will give a first preferential irrespective of signals and whatever the normal norms. So that's where policing is required, or the additional features or set of rules or laws or protocols, whatever can define them, will be or should be made available to satisfy that QoS. The network must control input rate and to at all connections, part of modern quality of service architecture for internet. So internet services and differential services, these are the two kinds of services that are to be discussed, or he is giving an example. So how do you deal with respect to traffics? So you are more concerned towards average traffic, or you are not more concerned to the current traffic as such. So there were some comparisons with respect to that. I showcase the slide whatever I have studied. So traffic's QoS guarantees. So best effort is basically end to end. However, you reach the from source you have started traveling, you will reach the other end. That is best effort. Internet services is per data stream. Currently, I am generating a data stream. What is a guarantee, or you are bargaining with respect to it is reaching the other end within 2 days? Maybe I'm booking some parcel, or will it reach within 3 days or 4 days? If it doesn't reach, what is the penalty, or so any compensation is given for me? So that is what is you bargain with respect to quality of services. Differential aggregate on an average it reaches by 3 days or 2 days whenever you are seeing that. So per session, so it is dynamic in nature. It changes appropriately with respect to the data stream because you are seeing aggregated or average performance is what you are dealing with. So then it is long term. So end-to-end domain-oriented, diff service is domain-oriented. So within a domain, want to see how much the service is provided on an average. But again, with agreed levels. So it requires support of RSVP or reservation protocols. We'll discuss that protocol in the following slides. So it is matured behavior and it is still has to be worked on. Fine. It's operational. Most of our internet services are best effort services. Almost most. Other than that, it also provides int serve and def serve. That is what is depicted here. So traffic characterization, admission control during connection setup. So it is as good as any admission procedure for that matter. Whenever you are admitted to engineering colleges or the medical colleges, so what is your input percentage? Say, qualifying percentage, minimum 50% in PUC and maybe some 50% in CET. Some norms or rules are being set up so that traffic becomes manageable. Or even I want to go further and say that there was a in our time in 2004 there was a lateral charge in TCS. So their policy was so say 70% and something some cutoff was stated and there was that was the era still walk-ins were more prevalent. What happened was so they expected 2,000. Now there are 10,000 applicants with 70% or whatever the admission control rule they have established. Now it becomes out of control. Now there was a latte charge and other things. So what is more important for me is there is some mechanism for admitting any message. So whenever somebody says that I want to go to that location through you or router or switch or any hub for that matter, it says to that can he be admitted? Will there be any repercussions because of the admission? So one new entry can spoil the entire ambience of the environment as such. So is it so? So all those entry cases will be looked after and then he will be admitted. Okay. So that is admission control policy or that is done during the setup of it. Sender needs to specify traffic characterizations. So ISP needs to agree. So you demand something and there is a bargain or negotiation after that, that packet is admitted. And once you have admitted that both have agreed for a service rules, whatever you have negotiated for, or that particular packet and internet service provider has negotiated for. Traffic is characterized by bounding the volume of data per unit time. So ultimately, it is not only who you are using the road or traffic, so there are others as well, and you should be restricted with respect to the loss. So an accurate bound on traffic can help reduce network resource that needs to be reserved. So you are going through the nodes and hubs, or different network nodes for that matter. Helps to reduce the resource idling so that there is always a traffic flow. You have allotted a bandwidth and there were mechanisms or the nodes that should be working almost 100%. That is what is expected. Okay. Gap times or the idle times should be lessened as far as possible. For traffic characteristic, many models have been proposed. So there are some models which we'll be discussing. So that with which you characterize yes, this can be the traffic as such. Now X minimum and S max model. It's again one more traffic model. The X minimum, the inter arrival time between the two packets is always less than X minimum. So he's speaking with respect to gaps between these two packets, whatever is delivered. So the size of largest packet does not exceed S max. S max is the size, the y axis. So what is the packet size that is being transmitted? So it provides a tight bound on CBR traffic or the constant bitrate traffic. So X minimum and S max is one of the model through which you can say to that this is the class of traffic that is coming in or going out that can be characterized. Average traffic ಅಂತ ಹೇಳಿದ್ರೆ then you divide that x min by s max, then we'll know the average traffic that is available with respect to that particular model as such. RNT model, the node satisfies R and R comma T if it generates no more than R bits per let's say duration T. So R into T bits traffic over any interval of time. So what he's showcasing here is it is a case of VBR. So CBR also can be fit over there, but most often he is also stating something with respect to what is it, variable time, idle time as well as the bit. So some can, it may be burst, some can, it may be spreading over larger duration and so on. So in whatever the manner the traffic is, what it has to satisfy is, so any interval of time, so under observations, r into t is the number of bits that is being transacted or communicated. Now it involves x minimum and s max. So previously we stated minimum interval between two arrivals or sending of a packets, and s max is the maximum amount of or the packet size that has to be transacted or communicated. Now with the observation period of I, so you also compute x average, or what is the average traffic that is moved with respect to traffic. It satisfies x minimum and s max model during any interval of length I average. So the traffic in that particular channel is x average. So average traffic rate is s max by x average time. That is what is being transacted with respect to that particular network. What you have put, so you have put a bounds on peak and average rates of the traffic. So it models more accurate with respect to VBR or variable bitrate traffic. Sigma and rho connection satisfies if you are during interval t the number of bits generated. So most often this is for burst kind of traffic. What is meant by burst is these times are more, there are more idle times. Suddenly there is a burst of traffic, so that traffic should be able to, this is average traffic, rho into t is average traffic, then there is a burst. So occasionally there is a huge rush of packets or the traffic is generated. So this is more suitable for the bursting node of kind of applications as such. Multiple rate bounding. Bursty traffic sources can be more accurately characterized by bounding the traffic over multiple averaging intervals. So that's what is stated over there. Because these are like a datasheet reading. So these are the few models available with which the traffic is characterized, and make somewhere sense that what is suitable for me can be decided by the designer. So R1 comma T1, R2 comma T2, it is with respect to the interval of time whatever the number of bits generated, and is bounded by that rate Ri by Ti. So as averaging interval gets longer, source is bounded by a rate lower than the peak rate and closer to its long-term average. So ultimately everything boils down to how do you manage your QAS. What is QAS? Quality of service. We stated that the delay, jitter, duration, or the propagation delay, bandwidth, and so on. So consisting of following components, whatever we stated initially was with which you characterize that. What really affects them, delay or jitter, is basically routing. So the packet may be standing in a queue with respect to router, or there is a FIFO or buffer in switch, and so on. So routing. So call admission control. So how do you start admitting any new packet that has arrived to a particular network node? So rate control. So in network, whenever you are stating that there can be networks are characterized by the traffic as such. There can be high bandwidth traffic, there can be low bandwidth traffic. So how do you interface a 100 Mbps data rate to some 56 kbps modem or something of that sort, lower data rates. So how to manage the rates. Then service discipline, while the call or the transaction or traffic is in process or is ongoing as such, how do you maintain the service discipline? So maybe suddenly I want to upgrade my plan from 1 mbps to 100 mbps, so on the go. So you are in the internet and suddenly maybe you want to see suddenly a HD movie. Other than that, you are doing some programming coding kind of applications which were not at all requiring large applications. And so any change in during the runtime, or how you are built with respect to voice over communications or whatever the services you are being extracting from the service provider. Then QoS renegotiation, as I stated, is basically you want to upgrade. There was a current plan, I was transacting with a lower bit rate or the lower jitter rate or the higher delay. So suddenly I have a requirement maybe for today or only for this much duration. I want a higher bandwidth. Then how do you negotiate with respect to different network nodes and get it done? So that is what is to be addressed with respect to QoS framework. So this is a core architecture of QoS. So it involves routing, admission control, service discipline, and QoS negotiations. Admission control test whether the required resources are available. So call establishment. So the required resources are reserved. Then call terminations. Once you are done with your service, then tear off that connections. So it is torn down. Uh, Admission control, as we stated, you check for certain criteria. So I give a very vague example of college admission with respect to CET cutoff and so on. So that similarly, whenever somebody comes with, I want to have a 10 Mbps data rate for a duration of 1 hour and some requirements. So he has his own QoS policies. So some service extractor or common man or the client wants a particular typical kind of traffics, whatever he has computed, he wants that. So whenever you accommodate them, you are also providing services for some other 10 people or 100 people, whatever your set is. They should not affect, because you have already agreed upon some quality of services with another 10 people. By admitting him, the ambience of the environment or that particular group should not be disturbed. If at all that is satisfied, then you can go for the admissions. So then there is a particular procedure or protocol. How do you admit a particular incoming node or the incoming traffic as such? That is called establishment. Required resources are reserved. So router reserves for every 10th slot is reserved for the new entry, so that he can send his packets onto the same channel or whatever, the if it is multiple access kind of stuff. Call terminations, whenever you terminate, and how do you really redistribute the available resources among the others, and take back whatever the resources are reserved by him. There was an establishment, now you have to remove that, so that that can be resources can be used much appropriately. Rate control, it ensures that source does not violate agreed upon traffic rate. So what it says is, I'm happy with the 56 kbps data rate, but suddenly if I tap or some other mechanism, I'm using more data rates. First of all, the service provider should not give it. If at all he is providing that, then the rate control should make sure that you are getting only whatever you have demanded for. Okay. So it provides resource to connections adhering to the reservations made during the channel establishment. You said 56 kbps, and your traffic is restricted, or that's where you are being monitored for 56 kbps and so on. QoS renegotiation is a renegotiation request can come either from user who wants to change his own QoS requirements, or there can be network due to the overload or congestion. So most often, if there is a network and for certain durations, he can request, and the Google or Yahoo server is going to down for another 2 days for maintenance, or this service is not available, that has to be broadcasted. So that is with respect to network initiated or the service providers initiated. Or you have gone for a lower range or with respect to cost criteria, and later part you want to upgrade yourself, then yeah, that can be done with respect to what are the payments and the reservations you can make through the negotiations. I'm just giving a vague example so that it is conveyed as such. So ingress and ingress, where the source of the traffic enters the network, and egress is where traffic leaves the network as such. So the remaining is your traffic control. So different nodes have their own rate control mechanisms. So you make reservations, and you are admitted, and then finally you are checked with respect to service disciplines, whatever you have paid for. So then if at all any upgradation either from network or from user, that QoS negotiation will be taking over, and that will be conveyed to the other nodes as well. Packet routing can help provide QoS guarantees to the applications. The route selection takes place during the connections and establishment for both unicast and multicast routing. So this maybe you deliver better than me because you have studied the computer communication network as such. Routing is basically you start from a node and there are different nodes through which you hop and reach the destinations. So in packet oriented network, there is no strict path, and hence most oftenly it is called as a virtual path. So every packet may move in different directions or different paths, but ultimately it reaches the destination because every packet contains the destination address. So whenever you are moving across, say as we have seen in the video as well, whenever a packet arrives at a switch or any particular node as such, network node ಬಂದ ತಕ್ಷಣ, it looks which is the channel which may lead you to the destination. So more suitable channel which may lead you to the destination will be chosen on your behalf, and you are made to flow through that. So whenever you are making that decision, so the destination address and hops or whatever minimum shorter distance or the cost and different criteria are to be evaluated, and then a particular node is assigned to you. So that how do you make sure that you are flowing through a particular shortest path, or the algorithms are there. So most often shortest path algorithm, say Prim's law or the Chase algorithm or ants algorithm, you have some mechanisms to identify this is the shortest path between those two nodes under considerations. So it may be cost, path, and any other criteria for that matter. It is as good as stating that in a network, so what is the shortest path between the and W? If it is bypass, yes, fine, but you also need to pay toll now. So the QoS policies will include all that, and whatever is required for that particular packet should be made available. Or paths that are unable to support the QoS requirement. Um, these algorithms are optimized with respect to the other metrics. So as we have stated, you have to bargain and make sure that it's not as simple as that I'm just playing around the shortest path algorithm or something like that. So there are many other criteria as we stated. It's not only about path, it's also about toll and other things. So the additional packets may be routed over paths that are unable to support. So whenever you are making that statement, he is keeping that the other things in mind. These algorithms are optimized with respect to the other metrics, and hence QoS routing and constraint-based routing has been proposed. So constraint-based is, to be very simple, it is not only shortest distance, almost free of cost, I should be able to travel from Dharavali or whatever the destinations and source you are stating as such. So there should not be buffering. So if buffer is include jitters at the other end whenever they reach there, and so on. The primary goals of QoS routing is select routes that can meet the QoS requirements of a connection, increase the network utilization, so that bandwidths are used much appropriately. Bandwidth is a very costly affair, and once you have allotted something, make sure that you use them much appropriately. To give an example, again I come back to cellular communications. That seems more promising for that. So cellular communication has some channel called as a BCC, or the broadcast communication channel, where maybe your locations are tracked continuously, home location or visitor location registers, because it's a cell through which cell in the geographical area. So one base station, if I say that it is serving somewhere around 5 kilometers with okay, 1 watt per kilometer of radiation kind of stuff. Whenever you imagine such a scenario, that uh, ಇದರಲ್ಲಿ network, so there are several other channels, say BCC and control communication channels. So most oftenly, um, maybe every 30 seconds or 30 milliseconds, whatever the duration, I am not very much sure about that. So they are updating your location. So whenever they are updating your locations, unless for that entire duration, it's almost idle. In that duration, if the whatever you see that SMS services or short messaging services were incorporated, so that those channels can be used much appropriately. Anyway, they are idle. So if you can make a calls and break a calls, that is through communication or control communication channels, so broadcast communication channels, wherever the bandwidth is empty, if that all becomes free, and then you send your short message services of 160 or whatever the amount of characters. Uh, Intention was to utilize a network utilization. So again, that example was, there should be some mechanism so that you can merge the traffic to that particular lane, or you can divide or take up the load from that particular traffic if it is congested, and put it on to some other roads or lanes as such. So topology of a network. So whether you have in a ring, tree, bus, what kind of architectures are chosen for establishing a network. Also requirement of flow, availability of resources, links, etc. Complexity of QoS algorithms depend upon the chosen QoS constraints. What are you are bargaining upon? Is your QoS constraints. So number of hop counts. That means I want to travel through minimum stops. So minimum hop count is basically so Dharwad Hubli example 100 bus. So Hubli Dharwad bus stations to Hubli bus stations, no intermediate stops or minimum hop count. So that can be one criteria. So delays again normally minimum hop count is also a lesser delay. Will may, assumption your presumption is you may reach faster. The bandwidth, so in my traffic I don't want to share anything BRTS kind of stuff, so that only my or BRTS bus is communicating over there. So you have a separate lane or bandwidth for which you have bargained or have paid for. So delay and jitter, there is no buffering or minimum traffic jams or signals in my road, so that can be one of the criteria. So jitter and delay, they occurs if I am just correlating with respect to regular traffic as such. So, yes, more signals, then more delay or more jitter can occur. So, if somebody can visualize all that entire mechanisms and decide this can be the best traffic, that is what is your bargaining at routing algorithms. So, DFI, comma J denote a chosen constraint for link I, comma J. So, additive constraints. So, for any path, it goes on adding. So one ಕಡೆ delay ಆಯ್ತಂದ್ರೆ then that goes on delaying further. So if jitter is introduced, that jitter reaches to the um, till the end. So cost is enhanced. We have paid multiple tolls. Now toll has been added up, and that is additive. So multiplicative constraints. So reliability of a path. So if reliability of a components goes on reducing, it is exponentially you are reducing the reliability has reduced. Speaking with respect to negative aspect of reliability, because this is also unreliable, this is also unreliable, and multiplies, so that the entire network becomes much less reliable. If both are reliable, so multiplicative constraints reliability of that particular path. Concave. So minimum of the available constraints is chosen as a constraint. So bandwidth. So whenever you are finding a path subject to or more relative constraint, release. Bandwidth is one of the criteria. Most oftenly, why do you choose a lesser bandwidth or the higher bandwidth ಅನ್ನೋಕ್ಕಿಂತ? So it is nothing like a lesser or huge. So bandwidth comes with respect to cost criteria, which is not showcased directly in this particular slide. Higher bandwidth ಹೋಗ್ಬೇಕಂದ್ರೆ say I want a separate lane for me. Whenever I make that statement, you have to pay for it. That means additional cost has been borne by that particular service extractor. So and service provider is able to provide that services. Whenever that happens, fine. Otherwise, most of the people will bargain for the whatever is bare minimum required for that applications. Okay, bare minimum in the sense, if I'm communicating with respect to voice oriented communications, maybe 56 kbps is should be there, or minimum that should be there. That is what you are bargaining for. So if at all available faster, then yes, you can communicate faster with the lesser delays and more quality as such. But whenever you are saying quality, what is minimum requirement, that is being spoken of. So proof of NP completeness. Uh, what is NP completeness is basically whenever you have a problem. So it is polynomial and non-polynomial complete, non-polynomial hard, NP deterministic or NP undeterministic or NP hard kind of problem statements. So whenever you scale up a problem, so maybe I'm computing with respect to 5 nodes, so that leads to for my router on the mechanism, some algorithm I choose. The time taken for making a next route or next hop addition is 5 seconds. If I increase the number of nodes to 1000, maybe time taken, maybe it is linear or exponential. There is some polynomial that has been computed. So NP complete is that computation time or is deterministic or If it becomes undeterministic, then NP hard problem. So all the considered constraints are independent. So this usually, that means polynomial equation where x square plus y square or whatever you are writing, that are the constraints, and some equations are incorporating. So can it be solved, or you are able to solve it, then it is NP complete. Unable to, many more iterations required, then NP hard. So the things are known priorly. Bellman-Ford or Jessa algorithm are the algorithms used for finding the shortest path. So computer routers using a hop count or delay and jitter constraints. Most oftenly, with respect to your computer communication networks, I feel you have studied them with respect to the shortest path algorithm. So bandwidth and hop count are more important constraints that are also can be done with respect to those two algorithms as compared to delay and jitter. Uh, uh, any comments with respect to this? So, as compared to delay and jitter, bandwidth and hop count are much more important. So, if I just map this, bandwidth is delay, and what is it? Hop count is jitter. So, if you have higher bandwidth, you may transmit faster. So, the entire bandwidth is available. No more number of bits transmitted per second. That's how what is really meant by bandwidth as such. So, and automatically delay gets lesser. So more transaction or more toggling per second. That is what is meant by delay. Jitter is uh, so there are lesser number of nodes, reducing the hop count. So whenever you enter a particular router or switch, so there may be separate FIFOs or queues maintained by them. And if I'm moving to lesser number of queues, then automatically the jitter will be lesser. That's how compared to Anukinta. So these are the root causes, or the, if I can manage these two, automatically this gets managed. Okay, anyway, his explanations, we will see that. Influenced by bandwidth and hop count, yes, he has stated same. Bandwidth is essential constraint for most of the real-time applications. Yes, because the message has to reach the other end within a stipulated amount of time. Hop count too large extent determines resource utilization. That means you require more number of nodes in the network as such. So multicast routing, whenever you are saying that unicast, multicast, and broadcast, unicast is between any two entities. Say there is a transmitter and there is a intended receiver, that is unicast message. So I'm communicating one-to-one communication, whatever you say, it is unicast. So smaller group, multicast, one transmitter and received by the many users for that matter, or the fixed number of the particular group, that is multicast. One transmitter to many simultaneously, that is broadcast. So multimedia applications require multicast QoS routing are becoming practically important. VoIP or video on internet protocol or video on demand. So point to point to between each source and destination becomes difficult. Multicast, the multi-point communications, why we went for that point to point communications or establishing connections for every individual or transmitter to source becomes difficult, or it is more impractical. Leads to huge wastage, and a multicast tree is connected, or connection is used. Okay. Find a tree routed source should cover all the receivers. Every path from the sender to each receiver should satisfy QoS constraints. So you establish a tree, and a message falls or flows from a root to leaves of the trees as such. So tree constructions, who is the focus? It is as good as master oriented or the outcome based education, or student oriented education. Similar to that, the construction algorithm for the multicasters, there are two types of the tree constructions. One is source based, so initiates construction from each source. Whoever wants to transmit something, say core based, a core is first formed and then each receiver joins the core. So that means there is a tree establishment. You can go on adding the leaves to the lower levels as such, and then they receive the transmission, whatever has happened. Okay, packet switch network. Again, I think we'll deal with this in the next class. Any questions, please ask. RSV protocol. Yes, any questions? Okay, then you can leave the class. So done for today.